We have just observed that using the distance time graph, we were able to obtain approximation of speed that is remarkably close to the true value. So how did we do this? By considering 2 points as close as possible. This is not good. This is better, 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 and we kept on doing this. And as and when we get closer and closer, as and when we got closer and closer, of course there is more room for improvement. So we did try to get closer and closer, and we can keep doing this. In mathematics, we make use of limits to discuss and accomplish this task. So limits enables us to help us in getting the most approximate value possible. So let's start off with a basic idea. So the basic idea of limit is that it's a language, it's an idea. It tells that we are near a value but not at that value. You should always remember this. Limits gets us as close as possible towards a value but never at that value. So the actual idea is, the fundamental idea behind limit is to bring a variable such as x as close as possible to the specific value and examine the behavior. Okay, so it's not about getting x value, it's about getting it to a point wherein we can examine the behavior of the function in response to this proximity, in response to this closeness. Limits allows us to analyze the function's behavior as the variable approaches the desired value without necessarily reaching it. Something like this. Say I have a variable red dot. The behavior of the function is not specified over here, but this red dot as a variable, it wants to reach to 1. This is what limit will do. So say it's starting off with -10. We are substituting a lot of values. So x is getting closer and closer to 1. But as and when it gets closer to 1, so it got closer to 0, but it pushes back, limits pushes it back and makes it travel again. Again, it's getting closer to 1, but again, it will push it back. It's like you can do better. And this keeps happening. So humanly, whatever was possible, I showed you guys. But yeah, the idea is that this keeps getting closer and closer. And doing so, we get a better idea of the function, its behavior at that moment of time. So we need to understand the language over here, limit of the function. For example, limit of the function, here the function was velocity, which was dependent on time. As time approach 2 seconds. So what was the formula? We basically made use of distance at 2 seconds minus distance at I second, actually in this case t second. This entire thing divided by 2 seconds minus t. So we try to do this basically. Okay. The next thing is, how will we read this? So in general, as x approaches a, f of x will approach m, then m is called the limit of the function f of x, which is symbolically written as limit f of x as x tends to a is equal to m. That's how we read it. Okay, so this is in general. So we read it as the limit of f of x, right, as x approaches a and it's equal to m. So it's not that different. We are just making use of a similar language that we know already. For example, if f of x is equal to x plus 2, f of 10 will be equal to 10 plus 2, which is equal to 12. So remember what we used to tell? The value or the result of this function when we substitute x as 10 is 12. It's similar to that, right? How we used to read it over there, it's similar to reading it over here also. It's a similar thing. So limit this particular expression s of 2 minus s of t by 2 minus t, as time tends towards 2, we got a range of value 19.95 meter per second to 20.05 meter per second. So in time, you guys will understand that why is that we are finding an approximate value, not the exact value. That you will understand in time, but I hope you guys understood the idea of limit.